So this is now question number 4 for Edexcel's FP1 June 2015 paper. Okay, so this question is all about imaginary and complex numbers. Remember, a complex number is a number which has an imaginary part and a real number. Okay, so anyway, the first complex number, Z1, well, it's not actually a complex number, it's a number. It's 3i, okay? Whereas the second complex number, Z2, is 6 over 1 plus I times root 3. Okay, and the first question it asks us is to put Z2, the second number, in the form A plus BI. Okay, so essentially what we've got to do is get rid of the third thing in the bottom, and that's naturally just, I mean, as soon as I saw this question, I thought I'm going to turn that into some kind of normal complex number. You can define a complex number as being normal. I'm not, so clearly this is not either. Now, with any complex number, we have to actually call, well, with this, we've got a third on the bottom, and we don't like a third on the bottom, okay? So we're going to use C1 knowledge. Now, you could say it's rationalisation because we're dividing one complex number by another, basically division there in Z2, but, I mean, you think about it as rationalising the denominator because essentially we've got a third on the bottom, and the imaginary number, I, is root minus 1, so technically that's a third as well. Okay, anyway, so Z2, I'm going to rationalise the denominator, so it's 6 over 1 plus I root 3, and we're going to times top and bottom by 1 take I root 3, okay, and you have to remember what we're trying to do here is we're just timesing it both, we're just timesing it by 1, essentially, but we're going to be getting rid of this third business on the bottom. Now, it's key as well to remember for this that because the imaginary number is root minus 1, so therefore I squared is root minus 1 times root minus 1, so therefore I squared is minus 1. Okay, so anyway, we're just going to times across and expand out. Okay, so it's 6 times 1, so it's obviously just 6, and then it's 6 times I root minus 3, okay, so that just literally becomes a minus 6 I root 3, nothing we can do with that. On the bottom here we've got 1 times 1, just 1, and then you could write in if you wanted to, plus I root 3 minus I root 3, but you don't necessarily have to because they will cancel anyway. And then the other multiplication you've got is I root 3 times I root 3. Okay, well the root 3 times root 3, well that's just 3, and then the I times I, well that's I squared, and we said I squared was equal to minus 1, so it's minus 1 times 3 minus 3, okay, so you do minus 3 from that, but because it's plus I root 3 minus, times by minus I root 3, we're taking away negative 3, so we're adding 3 to the bottom there. So this all cancels down, so the top becomes 6 minus 6i root 3 over 1, and the plus I root 3 minus I root 3 cancel, and then it's 1 plus 3 on the bottom, which obviously just simplifies to 4. Okay. However, we're not at the end of the question yet because it wants Z2, the second complex number, in the form of A plus BI. So we can cancel this down essentially. Okay, so we just put it as 1. So 6 over 4 is the same, 3 over 2. Okay, so we can write all of that again as 3 over 2 minus 3 over 2 I root 3. And now it doesn't say that A and B have to be positive. Sorry, it doesn't say A and B have to be positive integers. So don't be put off by the fact they are fractions. You think, well, naturally A and B are likely to be integers. Kind of read the question. Kind of helps. I don't do it, but you know, apparently it comes in handy. Okay, so anyway, that's part A out of the way in a very, very simple start. Okay, the second one is another bit that's quite easy. Part B says find the modulus and the argument of Z. Remember the argument is this angle business, and when it asks that, it's kind of nice to draw the diagram. That little diagram that I did do an example of in the argument video. I didn't have an argument myself. That's an FP1 topic, weirdly enough. Okay, so we need to give argument, give the argument in radians in terms of pi. Obviously, so when we're calculating this angle a bit later on, we need to do it in the radian mode in our calculator. Okay, so the modulus of Z2, is Z2? Yeah, modulus of Z, yeah, just check Z2. Yeah, okay, so as I said, that's just the Pythagoras theorem, really. Don't get that confused with the modulus in something you do in C3, if you've not done that already, where the modulus in C3, if you've done it, is simply just turning a number positive, whereas the modulus in FP1 is using the Pythagoras theorem. In other words, the square root of a squared plus b squared, etc. Okay, so a and b are these numbers here. Okay, so yeah, so it's the square root of maybe this isn't written so well here, so it's that's better. Okay, so a the first number is 3 over 2, so it's the square root of 3 over 2 all squared plus 3 root 3 over 2 all squared, and it's just a case of whacking them numbers into your calculator. Okay, and that will give you the modulus, remember, which is the square root of 9, and that also comes to 3. Okay, now the little diagram that I like to draw looks something like this. Okay, so we know our Z number is 3 over 2 minus 3 root 3 over 2i, okay? And you think of the first little bit as the x, okay? And the second little number, okay, the minus 3 root 3 over 2, okay, that's the I component. The I component is yeah, so it does kind of help to draw that 1 second. Yeah, so you think of the y-axis here as the I-axis, and then the first number is just kind of the x. That's the x. As I said, this is kind of crap explanation. But anyway, it looks like this, and I do a better explanation of the diagram in my tutorial, but this is just kind of assuming you know that. Okay, so anyway, the angle here is that one there, alright? And we know the modulus, okay, so we know this point here, which is 3, 2, okay, and then minus 3 root 3 over 2. Okay, and we know the length of this line is the modulus of Z2, which is 3. Okay, and using these coordinates, we know that the height of it is 3 root 3 over 2, and the length of it, i.e. that bit, okay, is 3 over 2. Okay, so we know that we need to find the angle of the argument, either, which I've labelled on there as theta, in terms of radians. So when you're calculating this in your calculator, analogy there. Analogy, don't know how it was. Just go along with it and accept it, and you watch a bit more of the video and we're all happy and you pass your exam. Well, you know, if you want to. If you don't want to pass your exam, it's fine. You can just turn up to the exam and die, and it will help other people pass. So your blessing will be taken into account. Anyway, so if you do that, that helps everyone else. But if you do want to pass on your own without dying, then you might want to watch a bit more. Anyway. Okay, so just find the argument. So totally up to you. You can either use tan, cos, or sine. Okay, and I think the easiest thing probably would be to do tan, because it's, well, actually no, it's not. So it's up to you. Okay. But anyway, theta, just to give you the answer for it, okay, is negative pi on 3, because remember, you can relate to that cast diagrams. The anti-clockwise is positive, the clockwise is negative. Okay, so it's the answer, the argument, okay, is minus pi on 3. Okay, so that is the answer for part B, and that's just a little bit of a guide. You didn't have to draw that little diagram there, but I personally think it helps quite a lot. Okay, and the next part, part C, asks us to draw all of this. Okay, so it draws Z1, Z2, and Z1 plus Z2. Okay, now that's Z2. Okay, that's an Agrand diagram. Okay, so is it worth? Yeah, actually, what I'm going to do is pause the video and tidy this up a bit so I can give myself a bit more room for part C. Okay, so welcome. This is now the latter bit of the question. This is part C. Okay, so what we're asked to draw. This is question 4, by the way. Sorry, I probably should say that. Anyway, so what we're asked to do is represent Z1, Z2, and Z1 plus Z2, where see Z1 is the first complex number, which we said was 3i. Okay, Z2, which is 3 over 2, or 1.5, minus 3 root 3 over 2 I. Okay, so what I've done, obviously we're also asked to represent what Z1 plus Z2 is, so we need to know what that complex number looks like. So it's simply just adding Z1 to Z2. However, Z1 only has a imaginary part, so really it's only an imaginary number, if you can almost think of it like that. Even though it says 3i, because it's 3 times I, we just simply associate it with the 3i. Okay, so what we end up with for Z1 plus Z2 is 3 over 2 plus 6 take 3 root 3 over 2i. Okay, and we'll have to represent each of these on the diagram. Okay, now it doesn't explicitly say, it says on a single Agrand diagram, so weirdly enough they all need to be on the same one. That's essentially what that means. That's the difficult maths out of the way. But what I want to get across here is we don't have to draw any angles. In other words, we don't have to work out the argument of anything. Now you could argue, that well, we've already worked out the modulus and the argument of Z2. Okay, so in other words, the second complex number here. So you could write that on, but it's not asking you to. So we're just going to go ahead and say we don't need to. The first one I'm going to draw on is the easiest one. Z1 is 3i. Now, kind of remember that the x-axis, what you normally associate with being x-axis, we call that as the real number axis, and the y-axis as the imaginary number axis. Okay, so in other words, Z1's got a coordinate, if you think of this as a coordinate graph of 0, 3, so it's exactly on the y-axis 0, 3, but really you know it's the position 3i. Okay, so Z2 is 3 over 2 minus 3 root 3 over 2. Okay, now we kind of already drew this on the diagram, so it's kind of easy to do. Okay, so essentially our Z2 went down here, okay, and you have to put the position on as 3 over 2 minus 3 root 3 over 2i. Okay, you might want to put 3i there as well. Okay, so that's our Z2, but we also need to label on what Z1 plus Z2 is. Now, hopefully you can see quite easily how we got Z1 plus Z2. We just simply added the like numbers together. Okay, so Z1 plus Z2, well, it's 3 over 2, so it's again a positive real number axis, so it's on the right hand side of the vertical line. In other words, what you normally associate is on the right hand side of the y-axis even. Okay, and it's plus, now it's plus, that means it's a positive y value, 6 minus 3 root 3 over 2. Okay, now it's the same distance away from the x-axis. Okay, so you just take this dotted line and continue it up. Okay, now it's not exactly saying explicitly it needs to be this distance high, so you just place it round about there. Z1 plus Z2. Okay, that's equal to 3 over 2 plus 6 minus 3 root 3 over 2i. Okay, now it doesn't say we need to work out these angles here, so you can just simply leave it as that, and that would be your answer. You did that squiggle there quite obviously. Okay, so hopefully that makes a bit of sense. Nice little end to the question, okay, to part C. As I said, simply just drawing the lines on there and knowing which kind of quadrants put them in really, and obviously labelling your points of where you put them, and the kind of little coordinate things, if you can think of it like that. So, very simple question. Thanks for watching, and well, maybe the first bit wasn't so simple, but anyway, thanks for watching, and we'll hopefully see you in the next video. You're going to put yourself through that again.